We're trying to bring a new approach to manufacturing environments, and that approach is probably best signified with the word learning by doing, or in a slightly different take, kinesthetic learning. I'm going to talk you through the context of manufacturing, in particular the context of small and medium enterprises, and then I'll show you models, because we're all model hunters, right? Process model, an activity model, and a workplace model, and I'll talk a little bit about the experience API and what exciting new ways we see there to track performance of learners, not only in the traditional sense with assessments and the like, but in the interaction with the real world. Manufacturing in Europe means that we're talking about 12.6% of the overall workforce that is working in that area. So of the around about 400 million people that we have in the European Union, there's about 225 million people in employment.
Do you think that you could just put this in PowerPoint view mode and collapse things around it so that we could actually see it in its color and not have it be quite so... Yep, there you go.
So that is maybe a little bit better. Okay.
Maybe you could even go up to the top in the... Yeah, right there. Maybe go up there to 50. Well, that looks better to me.
Okay.
Thank you.
Right. It's very significant of meetings like this that typically none of my end users is really in the audience, because we're looking at SMEs, at small and medium enterprises, and not at the big enterprises who have completely different capabilities of building AR, building up expertise in AR. So that's something maybe to keep in mind. If you find some of the things we do a bit naive, we do that for a purpose. Right. So that will be a bit challenging as none of my animations will work. We're piloting the work we do in 3 different areas. As you can imagine, manufacturing is wide-ranging. It goes from producing food to producing helicopters. So we chose 3 test beds that have enough in common to allow us to triangulate whether the stuff we do works, and maybe allow us to transfer it to different areas as well. So we're dealing with the aviation industry. We work with AgustaWestland, a global helicopter manufacturer. We're dealing particularly with maintenance jobs. We work with the textile industry, in that case with a cluster of companies in Germany. Together they have about 250 employees. And we work with the furniture industry in Spain with a rooftop training organization. They all share where about 750 SMEs are organized. They have things in common, but still every workplace is a different workplace. So I'll just shift that to the side here. Right. It's not only that the workplace differs, workplace meaning the locations, the objects, the persons or their roles. It is also the tasks that differ and the level of expertise that differs. That's something that we found in our workplace studies very much, that depending on where you are on the performance ladder, you need different type of support. At the very bottom of it, you find job performance aid that help people carry out tasks they're not really familiar with, whereas on the top you have people that are experts and typically find any sort of support pretty annoying and just want to get it out of the way. They are, however, the people that are required to create stuff and share it down here. They are the people that need the expert mode of any sort of support software that we have, whereas people down here rather need automated adaptation. We have built a process model that is by nature supportive of analytics sourcing and transformation. It has, I'm going to come to that in a second, it has built-in support for tracking and for performance measurements and benchmarking. it, as such, helps with sourcing training solutions, which is kind of the angle we have found how we can best enter into this SME scenario to help people find training content they're interested in and to help spice up existing training content. And that's maybe even the more important one with technology-based solutions. And of course, as always, we're aiming for reducing the efforts required to upgrade and continuously upgrade training solutions. Animation. We have distilled this learning process model from existing models supportive of creativity education, innovation training, lifelong learning, networked learning models, and came up with a model in which we put to the core the experience, and that is basically where a worker on the shop floor gets in touch with the different learning solutions. Output of experiencing something is, of course, tracking, tracing whether something happens, whether a user encountered a specific situation, whether a user consumed specific learning content, and so on. That's something we do with the Experience API. Typically, however, learning comes into play when things go wrong, when a problem is encountered. Ideally, a problem that someone else has solved already, but very often it's a wicked problem that no one else has solved already, which is something the inquiry step helps with, for which we have built a request widget, a support widget, that locates the learning need in sort of a taxonomy and helps identify potential mixes that can be relevant to a learner in that situation to help them remediate the learning need. In cases where no mix exists, there needs to be authoring support or networking support to come up with a quick fix at least. Mixes is something, and that's what I'm going to talk about in a little bit, we capture with activity models. Activity models describe what you have to do in sequence, and they describe what you need in each of the steps, including work tasks and including learning tasks. And there's one component I think that we quite brightly managed to put in here, that is a matching component that uses sort of semi-automated and automated technologies to validate whether a user has actually done a certain action step. For example, whether a user returned a tool to the toolbox, which we can track with Internet of Things or intelligent toolboxes, which is something our helicopter people are really, really interested in. They're frickless for safety. I see somebody not here, yes. Because as you can imagine, it doesn't really matter if you build a new desk with a drawer for a yacht and somebody leaves the screwdriver in the drawer, but it really does matter if you do so with a helicopter, as of course the machine would never be allowed to lift off and will be kept on the ground until the screwdriver is found, costing a lot of money. Other examples of such constraints that can be used to validate whether a user learned something or did something are user watched a video, or a user scored 14 out of 15 in a precision teaching assessment, or one use case we have been playing around with, user was able to do this activity using 20% less of energy than before. The matching component then uses these built-in queries and validates whether the user has done that, and can, of course, then provide reports and analytics that we use on Crunch being an analytics infrastructure that we have set up using RStudio for the web. And down from there are recommender systems that help in spicing up the learning content further, that help in improving learning activities further. In the work we did then with the different companies, we managed to distill 5 different scenarios that seemed to us generic enough, in which we see different needs with respect to support of AR or with respect to support of more complicated web contents. The 5 situations go from briefing to debriefing, and then in the middle you have the just about to be working on the job and the problematic wicked problem situation. And as you can see, from in the briefing situation, that is where you have the full attention of a worker, where you can deliver as complicated content, as long content as you want, but it changes, of course, the more you get into things. If you're working in a tail compartment, in a helicopter, in a confined space, you don't really want to browse long documents. You want to have the information just in the right place, maybe even with an overlay. So your need for AR is much higher than in different situations. There is also, and that's quite noteworthy, sort of a transition from the explicit to the tacit, from explicit knowledge to tacit knowledge, from the left to the right or from the right to the left. So to pick up Nonaka's famous Seki model of converting tacit knowledge in the heads of the people back into technical documentation, back into sharing with other people that might encounter that problem. There is a need, of course, from the debriefing then to feed back into explicit knowledge that can be reused. And I think with the model that we have chosen, that works quite well, although we're just moving into the first big wave of user trials now. So it will show if what I figure is really true. To make an example of such a AR on-the-job tutorial, as I like to call them, I've chosen this one here from one of our textile companies. This here is a Dornier, also famous for their planes, yes, but this is a Dornier weaving machine with lots of different parts. Some of the names I know by now. Typically, these machines produce meter after meter of fabric, and it is in the setup where most of the errors happen that give room for optimization and help to prevent excess material, waste of energy, and so on. And that situation becomes particularly relevant when the weaving processes switch from the winter to the summer cycles, when they switch from the summer fashion to the winter fashion, because the fabrics are essentially very different. Winter fabrics being more heavy and more dense, and that is where rehearsal of what you did 6 months ago, what the problems were that you encountered 6 months ago, how you fixed this specific type of error that nobody bothered to document, becomes particularly relevant. The situation as is today is typically you have such a spec sheet that says this is the way how the machine needs to be set up for that type of fabric. That's a customer sheet. Then you have the different parts. That's a weaving com here, I believe, and you reel out and reel in the fabric and set up the spoons, I think they're called in English. You hack in the pattern of weaving. And as you can imagine, that is a process that is time-consuming sometimes, needs a lot of checking back with the documentation, and sometimes errors slip in that, I don't know, the wrong Schlagbaum is calibrated and it should have been a rubber one, but in fact it was a metal one. The situation that we're working on is that we use cheap markers printed onto stickers put on the machine, simply because it's cheap. We do use feature-based markers as well, but it turns out that is a bit time-consuming, as you need to train, and there are even some objects, particularly shiny objects like a spray gun, for which it doesn't work at all. Once you move them, the reflections are so bad that the tracking just gets completely lost. We stick those stickers on the machine and we embed them then in sort of a workflow, a very simple workflow that in each step contains the validation constraints to see if a person can move on to the next step. Before I show you an example, let me quickly introduce you to our component architecture. We've chosen to separate between a web-based front end overlaying the AR engine in the back. The AR engine is responsible for the overlay primitives, like the markup of do not touch this object, do touch this object, and the like. But the actual instruction then and the workflow management happens in an HTML logic. They talk to each other, registering methods and exchange data in a way that it supports the whole activity. The user interface model is divided in 3 viewports. We have something on the left that we call Tinkerbell. That is where your tools appear once you have encountered them. If you need to nail together a piece of furniture, you probably need a hammer and a nail. So you find the hammer appears here. You find the nails, nail appear here. And then the whole activity can start, and you see actions here in the middle, and reactions such as answers to questions on the 3rd viewport. We've done so deliberately using the HTML overlay, so it allows us to configure the viewports with simple style sheets for different devices, so it not only works on an iPad but on glasses as well. Second example, that's a tutorial from the furniture industry. I'll just not bore you too much with a snapshot, but I'll show you a video that we recorded last November. This guy looks like me, but this is actually the head of varnish of a Spanish furniture company, just checking in now into the check-in area, personalizing the application using a badge. In the check-in area, I pick up my safety goggles and so on, moving on now to a spray boot, which is detected based on the marker. You see that the first activity boxes appear, telling me find a spray gun, find the fitting nozzle 13, which is the right nozzle for this size sort of paint. That's the chair I'm supposed to varnish. Varnishing sounds like a simple thing, but if you varnish for a boat that goes through tropical climates and salt water, you can imagine you have to do a few things a little bit different and a little more often to make sure that there's no saltwater damage and no corrosion happening. So it detects now the spray gun, and in a second as well, with a very cheap marker again, the right nozzle, which we've put into a toolbox here. And you see the objects appearing in the Tinkerbell. It allows to integrate job sheets, for example, with standard 3D overlays, which are all we're working towards the authoring side at the moment, so we're feeding this with an XML standard right now, but we're heavily developing a graphical user interface for authoring, which allows you to register overlays with XYZ coordinates offset to the marker, so you can put the chair on top of the marker and you can put a label here and a label there, being quite flexible in what you can augment. I think we'll see a second example, moving on to a different location now. Oh, no, that's a widget example, an instructional video included with a smart player that gives more information about the different segments of the video and shows how to properly spray the chair without creating any driplets. And if you do that varnishing process, you have to repeat these 10, 15 times, sanding, varnishing, until you can apply the finish. So here's another example of a different place on the shop floor. Luckily, in that shop floor, everything was already quite well separated in different areas, so we didn't need to placify anything. But that might not be the case everywhere. another instructional video example integrated about how to sand a chair, which is a rather simplistic example. I think if you need an instructional video for how to sand a chair, you probably have different problems as well. Yeah, the software still has a few bugs here and there, and I'll show a demo if I manage to log on. It's very flexible through the XML authoring solution, but it depends on how you use the technology, whether you do something intelligent or not, right? Yeah, so I thank my project partners, IDEMA in Spain, who helped us with recording this video. Right, interoperability. Talk a bit about the specifications we're building, which hopefully will become part of a standard at some point in time. I'll excuse myself that you will have to watch this now in pink, but otherwise it will be a bit difficult. The activity model and the workplace model we have differ from each other in that the workplace model describes everything that you could encounter in the workplace, which is most notably things, persons, places, but it also includes configuration information like what devices you want to consume your content on. Is it an iPad? Are these glasses? What software components, what widgets and apps are involved and how to launch them and so on. The activity model itself consists of a big fat container activity, which then has the different action steps inside of it. And each action step has an instruction, or can have an instruction, like find the spray gun, or find the spray gun nozzle size 13. It can have messaging attached. We currently use 2 message channels. One of them we have already integrated into the application, and that's the XAPI tracker. The other one is a real-time presence channel that we use to communicate, or will use to communicate between the different devices. So you can tap something on your iPad, you can open a widget in an ebook and launch something on your glasses. And the other way around, you can send something back to add additional information. The tracking just drops a message and a subject, predicate, object, triple to the endpoint. There can be software components that can be launched. We're working on integrating components called the role space to integrate widgets. Widgets meaning open social gadgets and widget 1.0 compatible widgets. And we have a chaining model. The chaining model allows an action step to define what happens if you trigger it. So if you tap it, if you encounter the object you're looking for and the object ID is sent back, or what happens if you do that a second time to reverse the activity. Depending on what you trigger, something new can be launched. We also support in the spec on enter summoning of other actions. So for example, you can put an action box out to the user saying, do you feel any back pain? Yes or no. Yes or no, then being the other 2 messages being summoned immediately. And if you tap, then a new activity can happen that shows you how to control your body posture in confined spaces so that you don't get any back problem. It contains also information about which viewport it shall be displayed in, which we'll see in a second in the workplace model, how we use that to configure and style the different viewports for different devices then as well. The constraint modeling is a separate bit in which we define the queries and control conditions, and the branching, then what happens if this control condition is violated, what happens if it is satisfied. And depending on that, then some automated validation can take place. Other non-automatically evaluable constraints have to be done through the user. We serialize this at the moment as an XML specification, mainly for the reason that it allows us to completely reorganize the specification almost every single day. No, I'm joking. It has become quite stable by now, but we still see demand to improve in the one or other area as we're progressing, and the XML spec allows us to do that easier, quicker.
Quick question.
But
is XAPI? You mentioned it before as an activity stream mapping. Are you going to show where it's being used?
So an example here is, you see here a message type trace on a channel called Learning Record Store, which is an XAPI endpoint, which drops a statement basically to the XAPI endpoint. Everybody familiar with XAPI? No? It's an API which allows people to log anything and everything. The standardized format with which things can be logged are someone did something, and all three words can be replaced with whatever you want. Fridolin watched video. Christine listened to Fridolin. That sort of thing is what you can model. There is a standard vocabulary proposed by the ADL about what verbs you can use in such a logging statement. We've already seen that this is too short for AR. For example, there's only one verb really about object encounters, and that's called interacted, and that's a bit too simple for at least our use case. So we're working on concocting a better object handling vocabulary that we want to put into our XAPI endpoint, so we can measure more interesting types of performances. But this is basically where it happens. It's modeled here in a message.
Is XAPI open source and available? How can people learn more about it?
So you Google for XAPI and ADL, and you will find the website of Rustici software. There is open source implementations available in various languages. We are currently working with an implementation from a small company in Oxford, an open source implementation in PHP called the Learning Locker, which fits better to our university's technology universe than the Python implementation or the other implementations around. Typically, this is a component you just run and you interface then with the JavaScript wrapper. That's what we actually do as well. The workplace model, and that connects, I think, maybe nicely to the work that has happened so far about standardization in the group Christine is leading. But going a bit beyond that, maybe, in the sense that we distinguish between three different types of resources, which are the configurables, devices and apps, the tangibles, which are persons, places, and things, and the triggers, we call them triggers, the markers and the overlays. In the marker case, I think that's quite straightforward. We define a marker, we give it a uniform resource name, so it can be uniquely identified. Any person, anything, any place, then just points to the marker it wants to use. If it's a printable QR code-like pre-trained marker that ships with the app, you just print it, stick the marker on the object. If it's a specially trained feature cloud, we are looking into how we can exchange the feature cloud marker data in a way that you can do an in-app purchase for, I don't know, the standard tool box of a aviation industry worker, so that your tools can be recognized already. Probably there's a sort of there should be the same sort of gold rush feeling about creating databases with markers as we had 10 years ago with map data, in my opinion. We're talking, for example, to DIY.com if it's possible to get all their images of all their tools for all sorts of areas. We'll see. The not so straightforward area is probably the overlays, I think, as they have two sides. The overlays are any sort of overlays, not just the visual ones. We shouldn't forget that AR is not only visual, it can be auditory, it can be gustatory even, it can be olfactory, it can be somatosensory, like vibrations or stuff like that. Of course, the ones we've started with are auditory and visual, and we have defined a couple of primitives for them. Simple primitives such as yes-no overlays, like touch this object, don't touch this object. Labels, like positioning, a label should be displayed here, or image overlays or animation overlays. Similarly, with sounds, we have designed a few sounds for encountering a person. Another encounter of the third kind is encountering a thing, encountering a place. And we are now moving to the next level where we want special animated overlays with a good set of motion verbs, of handling verbs, so that you can have a normed sort of visual animation showing push that button, push, reverse, throw away, and things like that. So if anyone has a standard set of vocabulary we should support here, we have a very open ear. It's clear that these overlays are primitives, but there is a kind of reference side in which you need to configure them. So if a person supports, if a thing supports the lift overlay or the push overlay, it needs to specify where this should be displayed with respect to the detected marker, XYZ coordinate, offset, and so on. Or if it supports an image overlay, it needs to specify a hyperlink to the image file. If it's a label, it needs to specify the label value to be displayed. Right, but I think with that abstraction, of which you see here again the XML serialization example of a specific place, of a specific thing, of a specific person, I think we've made a quite good step forward to allowing authoring on a level that is straightforward, even for the non-enlightened adept, I think. Yeah. Another example here, maybe I'll jump now back into a better color scheme. This is a snapshot. Yeah, a little bit later I need to log in. This is the XAPI endpoint. You see here my statements, what I did 2 days ago. I launched a certain activity which had certain action steps. I encountered specific objects which launched then again new actions. You can see that basically everything on this very simple interaction level is currently captured, and we can pull out now interesting reports such as, I don't know, social interaction between people, interaction with objects, time it took, performance measurements, and so on and so on. Right, I think I'll stop here and give you a chance to ask questions about what we're doing.
Great. Okay, thank you.
Just one question. So, once you had your coding or API in place, how did you set it up? I mean, how did you have just set up simple tasks and then had it learn the rest of it, or did you have to go through and do industrial engineering to actually follow the whole process?
You mean the activity models now?
Yeah.
So what we've done is we went to the companies and studied their most prototypical use cases and built a couple of them so as to find out where the difficulties are. in the next phase that we're now preparing for is we're going back to them, and we run a couple of workshops on authoring experiences, so we can figure out where the difficulties in authoring are. And we will probably release towards September the first graphical user interface for authoring. And then we'll go into the second development iteration cycle to improve things and get them completely right.
I had a question on your use of Experience API for generating messages, and so what are the sources that you have leveraged now, and then have you, or are you looking to start generating messages based from the equipment, based from Internet of Things, from sensors in the environment, or any other sources?
Yes and no. So currently we're logging only from the ARC application, but nothing keeps us from allowing any of the other software components, like a widget that is launched, to log stuff as well. For example, if you have an assessment exercise, this assessment exercise runs in a widget and you score with a certain performance, it's open to the widget to drop statements to the endpoint as well. Or if you have a book and you log in at the beginning of the book and you progress chapter by chapter, you do an interactive exercise here, an interactive exercise there, we can build them in a way that they log stuff as well. In some cases, it's easier to just build it in the player application. In other cases, that would be way too complex to generalize it, and it's easier to build it actually within the widget. With respect to Internet of Things applications, I don't know yet. Our lead partner there is TXT in Italy that have to do with the Internet of Things component. And I understand there is a wrapper in which the logging probably will take place. It's not necessarily in the sensor. It's sitting somewhere on the message bus, receiving the messages from the sensors, and then translating what you want to feed back into the experience locker.
Yeah, I thought it was interesting. I've heard other description of a manufacturing app where the rich data set is already generated by the machine, right? So it has monitoring and all that. And you could either try to capture that data into your message path, or with Internet of Things, you could like tag sensors onto a machine and generate external data, like create your own sensor network around the machine and use that. So if you turn the dial on steam and the temperature went up, you could actually capture it.
So it's not straightforward, since we're logging here the learning experiences. And for example, if you take the Dornier weaving machine, I think typically it depends on the fabric, and the setup, of course. But typically, this generates thousands of potential faults if you use automated monitoring systems such as Cyclops, the camera thing that looks at it and spots any irregularity in the pattern. There are, of course, with a false positive rate, a large number of pictures that would be gathered in that case, and feeding them into the learning locker wouldn't really make sense. That would have to be a different component. You wouldn't want to mix this with the human performance data, as it's on a very different scale. Yeah, I guess the same is the case with Augusta Westland. I'm sure they have some IoT components within the helicopters, all these systems inside. It's a different type of data that needs to be filtered, I think.
I'd like to take one more question, but what I'd like to propose is, in order to keep us moving and the time schedule that we have two more sessions, two more 30-minute sessions. One's going to be about the AR interoperability, AR browser interoperability, and then another one is about open source and web-based AR. And those are 30 minutes each. After that, starting from 4:30 to 5:30, is a time that's designated for demonstrations. And I think that would be the best time for you to be able to show us what you've been doing and how it works, given that our time constraints today. And then I'd like to encourage you to take your questions to Fridolin during that demo time at the end. We built in that flexibility so we could have that sort of hands-on experience and exposure to these new platforms and new products. Is that okay?
Sure.
Thank you. One more question before we leave the subject of this workplace reference model for AR. I'd like to see a show of hands if Fridolin were to host a 1 hour, so he just gave you a 30-minute briefing about it. If he were able to host a 1 hour or a 2 hour briefing on this subject, how many of you would want to participate in that? Hold hands way up high. Okay, good. So let's just take that as an action item. We're going to organize a between 1 and 2 hour focused workshop just on that reference model, defining the activity model and the workplace model, getting more feedback, more interaction, more detail so you can see it better. All right? So I think it's not perhaps the very, very first time that anyone's heard about the work that the Tell Me Project has been doing, but this is really up to date. This is what's happening right now in that project. It's $8 million over 3 years.
Euros.
It's 8 million euros.
Even,
This is a lot of money. And one of the things that they need to be able to demonstrate in return for that money is that they're having an impact on industry, and that they're having that this is needed, that this is valuable to someone. So let's make sure we show them how valuable we think that work is. Okay, thank you.